Okay, so welcome back. So a couple of things I'm going to spend some time on. I'm going to spend a couple of minutes, not even that, I'm going to spend less than a minute talking about domain and range of the cosine and sine function. Okay, so again, we're talking about a unit circle. Okay, so again, this is 1. Okay, and again, this is all 1, 1, 1, 1 all the way around. Okay, so the domain and range of a cosine function and sine function. So keep in mind, remember that this is on the unit circle. So again, x represents cosine theta, right? So again, all you have to do is mentally realize that, hey, what are the values of x can be? Well, x can be as small as 0 or as large as 1, or if you're over on here, as it goes back and forth. So remember, let's say this is on a sliding hinge or wheel that goes all the way around, and this slides up and down, and this slides, or excuse me, side to side, and this slides up and down. Okay, and so as I walk this all the way around, what's happening? Y is going to get to here, right? So y will become 1, and then it'll start to go down here, and y will become 0, and then it goes down to -1. So 1 to -1, 1 to -1. And so what happens is the largest x can be is 1, and then the smallest x can be is -1. And same goes for y. So that means the domain, and since x is equal to cosine theta and y is equal to sine theta, then that tells us that the domain and range of sine and cosine are both 1 to -1 to 1. Inclusive. And that's it. That's all I'm going to say about domain and range of cosine and sine. Okay, so now let's talk about reference angles. Okay, so we talked about reference angles before. And so again, a reference angle is just the smallest acute positive angle that is made with the horizontal axis. Okay, and so far we've dealt with angles that were between 0 and 90 degrees, right? Here in the first quadrant, right? But the question is okay, well, what happens if our angle is in the second, third, and fourth? I've kind of touched on this in the other videos, but now I'm going to make it clear, okay? So theta can go from anywhere from 0 all the way around to 360 degrees, right? The reference angle, which I'm going to call alpha, is going to be the angle, right, with the x-axis that can be represented in the first quadrant. Okay? So, and there's always going to be an equivalent reference angle here in the first quadrant, as you'll see. Okay? Now, what if we have another angle, and let's do this one here. And I'm going to try to do this the same. Okay? Not that I'm going to be good. Okay? And so let's say this is theta. Okay? But the reference angle is going to be this angle here, right? It's the smallest positive acute angle, right? With the terminal side and the closest horizontal axis. So this is what we're going to call alpha, right? Okay? So let's say this is equal to this, okay? Or we can go ahead and extend this line. Let me get a different color. Let's use orange. Okay? And so now, what am I going to do? Theta now can be represented by this, right? Orange. So now theta is this angle, but again, the reference angle is going to be this angle here, right? And then finally, let me get another color. And so again, now I'm going to have theta there. Oops, let me do. But then, that's going to be alpha, right? So alpha represents these. Now again, I did this on purpose. I'm representing the same angle. Okay, I want all of these angles to be the same. And so my point that I'm doing this is that any of these reference angles, and I'm drawing these so that all of the reference angles are the same. All the reference angles has an equivalent reference angle in quadrant number 1. The only difference is the value of x and y. Now over here, right, if I was to draw this triangle, right, here x is negative and y is positive. So what does it tell us? Now here, over here, y equals, or x equals cosine theta, and y equals sine theta. But over here now, x is negative. So when you're in the second quadrant, what? X is equal to negative cosine theta, y is equal to sine theta. So in quadrant 2, your y's are the same, but your x's are opposite, right? What if you're in the third quadrant? Well, now we've got this triangle, right? And so again, my circle's not the best, so just pretend my triangles are the same. Well, now what happens? Now x's are the same. If I compare this with this, right? Here now my y and x are both negative, right? So here x equals negative cosine theta, and y equals negative sine theta. And then in the fourth quadrant, what? The fourth quadrant, x is positive, but y is negative. And so over here, what do you get? You get x is cosine theta, y is negative sine theta. So all you have to do is basically just remember the values of x and y. Really, I mean, that's all it comes down to is realizing, hey, if I'm in the second quadrant, x is negative, y is positive. If I'm in the third quadrant, x and y are both negative. And if I'm in the fourth quadrant, x is positive, y is negative. And of course, they're both positive here in the first quadrant. So both positive in the first quadrant, both negative in the third quadrant. Opposite signs here and here, but y is positive, x is negative. X is positive, y is negative. Okay? And that's really all you need to remember when you're dealing with reference angles. So now what you could do is you could find the reference angle for each one and then realize that, hey, I have another reference angle here. So if I have a 30-degree angle here, right, in the third quadrant, well, I know I can have, that means I can think about this in the first quadrant, but realize that I'm just going to have to make sure I pay attention that both of these are negative or opposite signs of what I get here, okay? And that's why we spent our time in the first quadrant understanding if I know what those angles are, what those cosine and sine of those angles are in the first quadrant, then I can basically easily translate that into second, third, fourth quadrants by just realizing which ones are opposite and which ones are the same. Have a great day.